Alright, hi guys, welcome back. Please check your answers for the expected counts that you were calculating. Um, the purpose of all this, having an observed count and an expected count within the same cell, is that we're going to calculate our chi-square statistic, which is this measure of how far away the observed counts are from the expected counts, and we've done this before. Think of chi-square in this paragraph here, think of chi-square as the measure of the distance. I just can't get that highlighter going. Here we go. Think of chi-square as the measure of the distance from the observed counts, of the observed counts from the expected counts. Okay, it's a distance. It's either 0 or positive. Okay, there's no negatives here for chi-square. Large values are evidenced against H0. The larger your chi-square is, the more evidence that you have that there's some sort of relationship between the values or the categorical variables in your two-way table. Okay. So your alternative hypothesis is that there is evidence that there's a relationship between two categorical variables, and although in a way that's many-sided, the actual process that you're using is a one-sided, one-tailed test, okay? Because any violation of H0 tends to produce a large value of chi-square, because there's no negative values of chi-square, unlike a normal distribution where we had positive and negative z values or t values, for instance. As far as when we can use chi-square, I've listed the rules here in the box. Basically, 20% of the expected counts, no more than 20% of the expected counts can be less than 5, and every count has to be at least 1. And then there's a special rule for a 2x2 table, but you guys should know that anytime you see things that are less than 5, that you should proceed with caution anyway. Alright, so we are going to calculate the chi-square statistic by hand just this once so that you guys can get a feel for what's actually going on here. So what you do is you take all of your observed values. So I'm going to go left to right in the table from the previous page and just list all the counts that we had. 35, 49, 16. Okay, so I'm just kind of copying this table here. I'm going left to right and then down. The expected count associated with each observed number, I'll write next to it. You can just follow along. 30, 50, 20. Okay. How do you calculate chi-square? Well, you subtract observed minus expected, and I'll do that in a row. Okay. Let's see, 25 minus 16 is 9. Got negative 6, 11. 35 minus 30 is 5. 49 minus 50 is negative 1. And 16 minus 20 is negative 4. Now, why don't we just add these differences up? Well, you can see that there's positive numbers here, there's negative numbers here. They would wash each other out. And you might get something that's 0 even though these numbers were huge. So the way that we get rid of that is by squaring, because of course squaring always produces a positive value. So we square all these numbers, get a list of positive numbers, okay? And then we do one other thing. This is all in relationship to the expected count. The expected count is a very large number, then perhaps 100 isn't that big of a deal. So you go back and you divide by E, the expected. So some of these numbers are convenient, some of them are not. Okay. Let's see, we get 25 over, let's see, 24, 25 over 30, 1 over 50, and 16 over 20. Okay. When you add up these numbers, which are mostly decimals, some of them not so convenient, you get a chi-square statistic of 13.316. So we've had much larger than that, you might be thinking. So maybe this isn't so improbable, but this really all depends on degrees of freedom, right, guys? And I haven't actually mentioned how you get degrees of freedom. So I'm going to skip this box right here. I'm going to go down to the next box here. And here is a rule for finding degrees of freedom in a chi-square test of independence. You take the rows in your table minus 1. There were 3 rows in the original two-way table. And then you take the columns in the table and subtract 1. There were 3 columns in the original table and subtract 1. So you get 2 times 2, or 4. There are 4 degrees of freedom. Okay, that's going to help in a second when I have to look up my chi-square statistic on the table. Alright, so we're going to finally bring this test to a close. Okay, just to get us back to the beginning of the problem. Okay, our null hypothesis, our H naught, is that there is no relationship between keyboard and we'll call it speed at which typists learn. Okay. Our alternative is that there is a relationship. Okay, they are related somehow. Okay, I'll put an ellipsis there. I've kind of run out of room. Since an alpha was not stated, we'll go with 0.05. Alright, we computed the chi-square statistic. It was 13.316, and there were 4 degrees of freedom. Okay, so what we need to do is consult the table, which I have here. Our chi-square statistic for 4 degrees of freedom was 13.316. Now I see 13.28. Okay, I see 14.86. If you look up here, the associated probabilities are between 1% and half of 1%. Okay, so our lower limit is half of a percent. Our upper limit is 1%. Okay, it's between 0.005 and 0.01. Okay, so basically it's less than 1% probable that this would occur randomly if there's no relationship between keyboard and the speed at which typists learn. Okay, so P is definitely less than alpha. Okay, so we will reject our null hypothesis. There is evidence to suggest that the keyboard type affects the speed at which typists learn. Okay. Now, great, that's probably what you suspected all along. This is kind of an initial test that we do, and then you can dig deeper into the table and start comparing 2 samples at a time using other methods that we've studied in this course. But it kind of gets the ball rolling as far as whether you should even dig deeper into the data or not. We will utilize your TI-84 when I return, but I needed to go through this so you understood all of what your calculator is doing for you. So hopefully that makes sense. At this point you can go work on your projects, and I'll be back tomorrow to do a little bit more chi-square with you. Thanks.